what is it, page 10. And let me tell you about, there's one theorem, yeah, I guess not a postulate, just one more theorem, for right triangles. It only works for a right triangle, so you have to have a right triangle. If you don't, then you cannot use it. And it's called HL. It stands for hypotenuse and leg. And I already filled it in for you here. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the matching leg, corresponding leg of another right triangle, then the triangles are congruent. Now, up here on mine, I made it bigger in the boxes, but you also, under here, as I said, for right triangles, there's also LL, HA, and LA. However, HL is the only new one, actually. So, LA would be leg angle, HA would be hypotenuse angle. The reason, you do not have to know those. The reason is because if you have two right triangles, let's say we're doing HA, hypotenuse and an angle. You don't have to know HA, HA, because it's just angle, angle, side. So all of these will still work for right triangles, but you have one more that you could use. Okay. So you do not have to know the other three of L, L, H, A, and L, but those are actually just, it's going to be one of these that we know. That's what those are for. Okay, so only one proof with that, and one at the bottom. This section I call right triangles and overlapping triangles. There's nothing new with the, I'll tell you in a minute, with the overlapping, it just looks different. So any thoughts on HL before we move on? So let's do a two-column proof in this one to show we're proving ML is congruent to JK. Okay, that's what we're proving. So the other information is the given. Okay, so let's write down. It says given that JM is congruent to KL and angle JKM is a right angle, and so is angle L. Okay. So good on the setup here. Let me mark JM congruent to KL. So we're trying to show ML is congruent to JK, and as normal, we will show the triangles are congruent. And if the triangles are, then certainly, what did I say? ML and JK will be. We use this, right? You're going to use all the given. We use this one, marked it. Before I use these, can we go ahead and do a shade sign? Reflexive property. Okay. Kenzie, you want to help us out with what you think it would be?
Is it MK is congruent to AM?
Because it looks
Really?
like, cause it looks like quadrilateral. I think that's a good rule of thumb. It looks like quadrilateral. The triangles together do. Then you got to turn it around to be KM. Yes, but it's still reflexive. Reflexive property. Okay, and I marked in my diagram. I have two sides, which is great. I only need one more. Actually, I apologize. These four, you always need three parts, right? In HL, you only need two parts as long as it's a right triangle. And I didn't draw it in yet. But
I was gonna say, like, couldn't you already have it because of the right angles?
yes, that's I just hadn't drawn these in yet. So JKM is a right angle, and LMK is a right angle.
How do you know? Oh, it says something.
Yeah, it was given. Okay, now normally with this, we didn't have to say they're like for these, like angle side angles. We have to say all right angles are congruent and name those angles as congruent. But you're right, we just have a right triangle now, so So we're set. We don't need any more parts. We have two. Let's make sure we have, in this triangle, we have a hypotenuse and a leg. In this triangle, hypotenuse and a leg. So the triangles will be congruent like HL. Triangle, well, let's do JKM, congruent to triangle LMK. And before I finish the last step here, I wanted to say, the significance of HL is this. If we didn't have HL, this one would have been two sides, and the angle is excluded. It would have been, and that doesn't work.
So it's not side, angle side?
It is not. The angle would have had to been here if you wanted to use SAS. So the significance of HL is it's actually angle side side, but for right triangles it works. Okay. So yes, you can never write this, but the angle side side version of right triangles is HL. So to finish up, we said the triangles are congruent, and therefore these segments are parts of the triangles, so they're also congruent by CP, CTC. That's, I mean, so just one more new one. It has to be a right triangle, though, in order for you to use it. Hey, something else, this just a quick aside here. They actually, OST just brought HL back in this year. We used to do it for many years, and then they took it off 2 years ago, and they updated the standards. It's now back in there. So.
Good thing we're learning it then.
Yeah, otherwise you wouldn't have needed it. So thoughts on HL? Approved?
You wanted to do that?
So now let's do one at the bottom. This is an overlapping triangle. Basically, as I want to say this, there is absolutely nothing new. And you're just going to show that the triangles are congruent, and we're going to then say CP, CTC that these segments are. I say there's really no difference. However, it's sometimes difficult to view the triangles. So a simple redrawing of the triangles can be helpful. So what I'm going to do is do this proof. I'm going to show you on this diagram, but then I'm also going to redraw the triangles so they're not overlapping, so they're separate. And you can see how it lines up. So you never actually have to redraw the triangle in this, but you can. Okay, so we're going to have two sets of angles congruent, which is good, and that's a lot. Okay, so what I'm going to do is I'm going to redraw the triangles separately just so we can see it here. And then it's your choice. If you like redrawing them, great. If you like just, you can see them together, that's fine as well. So I'm going to mark the givens. ACB congruent to DBC. And ABC congruent to DCB. I'll put them up here as well. So it's that angle and this angle. See, this is why I sometimes redraw them, because marking them, then here's what I'm going to have to do. Like it's that angle and this angle. It just gets a little busy. There's just a lot going on just to see you right there. So I mean, for me at least, redrawing them, wow, it's just very clear. I can see it a lot better. So let's say the triangles are congruent, and then we'll say CP, CTC that these are. They're not right triangles, so no HL. We have two angles. We need a side, right? We can't get the triple A won't work. There's no other givens though. We did these. Anybody see something up there we can do though? It's a normal one, but it's a little bit hidden. Doug?
Shared side.
If you redraw them, it's just BC and BC are the same. But if they're overlapping, they do just, it's a different way of overlapping.
Does that one matter how you do? You have to a certain way in this one
What BC?
is congruent to.
My rule has been broken, I'm just noticing. Because it's B to C in this triangle, and then it's C to B in this triangle.
Wait, so if I put BC is congruent to BC, it would get points taken off?
Just write it as BC congruent to CD.
Yeah, but then I'm gonna forget.
So in the first drawing, yeah, I'm just marking that shared side. For me, it helps to know, especially which triangles are congruent. If so, by separating it. I separate it, there's two angles and a side. Two angles and a side. And the side is between them. So it's going to be angle, side, angle that shows the triangles are congruent. So I'll just say triangle ACB congruent to DBC. I'm just looking at the first angle given using that order of letters. Alright, and since those are congruent, certainly AB and DC will be.
Some of them are gonna go with that, but I like that.
CPCTC. Oh, an overlapping triangle? Yeah, definitely could be. Just
These ones are nice. This is fun. That was
Really?
fun.
Only one
Oh
That
my
was fun. Probably
goodness.
the only one that stopped.
No,
The
it's
thing
like
that stopped talking.
We
It's like
got
a
it.
logic puzzle.
wow, you got that. That was